Summation n starts from 0 to infinity 1 upon 3n plus 1 minus 1 upon 3n plus 2. Evaluate the value of this. Since we know that the power rule in integration is integration of x to the power n dx is equal to x to the power n plus 1 whole divided by n plus 1 plus of constant. Using this, we can see the index here after applying the rule becomes n plus 1. With the same analogy, we try to figure out that this 3n plus 1 can only come when this index here becomes 3n instead of n. So I'll rewrite the expression as summation n starts from 0 to infinity. I'll write 0 to 1 x to the power 3n dx minus integration 0 to 1 x to the power 3n plus 1 dx. So on evaluating this integral and this integral, we get 1 upon 3n plus 1 and 1 upon 3n plus 2. So we just took the reverse step here, rewrite it as like this. Now the summation will act inside the bracket and will take the integral common. So this becomes 0 to 1 summation n starts from 0 to infinity of x to the power 3n minus x to the power 3n plus 1 with respect to dx. Now applying this summation inside the bracket, we get 0 to 1 integral x to the power 0 x to the power 3 plus x to the power 6 plus so on up to infinity minus x to the power 1 plus x to the power 4 plus x to the power 7 plus so on up to infinity with respect to x. This series here and this series here is a GP, if I can see, and here the common ratio is nothing but x cube, and in this series the common ratio is also x cube. So infinite sum of a GP is nothing but a upon 1 minus r. Applying this, we get integral from 0 to 1. First bracket becomes 1 upon 1 minus x cube minus second bracket becomes x upon 1 minus x cube with respect to x. On further solving, we get 0 to 1 integral 1 minus x whole divided by 1 minus x cube with respect to x. Since we know that a cube minus b cube is equal to a minus b into a square plus b square plus ab, applying this in numerator, we get integral from 0 to 1 minus x as it is whole divided by 1 minus x into 1 square plus x square plus 1 into x dx. Now cancelling the common terms 1 minus x and 1 minus x, this becomes integral from 0 to 1 upon x square plus x plus 1 into dx. Make perfect square of this expression here now. So we write x square as it is plus we multiply it by 2 and divide by 2. X remains as it is plus 1 as it is. Now this 1 by 2 is giving us a hint that we should add and subtract square of it. If we can see that this expression will give us the perfect square, so this will become x plus 1 by 2 whole square. 1 and minus 1 by 2 square becomes 1 minus 1 by 4, which eventually becomes 3 by 4. So I can write here plus 3 by 4. So this becomes integral from 0 to 1 upon x plus half whole square plus 3 by 4 dx. And if I rewrite it again, if I rewrite, I can write this as integral from 0 to 1 upon x plus 1 by 2 whole square plus, instead of this 3 by 4, we write under root 3 by 2 whole square into dx. Since we know that the integration of 1 upon x square plus a square with dx is equal to 1 upon a tan inverse of x by a plus c. Applying this here becomes 1 upon under root 3 by 2 tan inverse of x plus 1 by 2 whole divided by under root 3 by 2, and limit starts from 0 to 1. This becomes 2 by root 3 tan inverse of 2x plus 1 upon root 3, limit starts from 0 to 1 on simplifying. Now using the limits, we get 2 by root 3 as it is, tan inverse of 3 upon root 3 on putting 1 minus tan inverse of 1 by root 3 on putting x equal to simplifying 2 by root 3 remains as it is, and this becomes tan inverse of root 3 minus tan inverse of 1 by root 3. Tan inverse of root 3 becomes pi by 3, that's the standard value, and tan inverse of 1 by root 3 is pi by 6. On simplifying becomes pi upon 3 root 3.